put up these equations out there, and I wrote them earlier prior because I didn't want to induce jitters during videography. So this is the formulaic equation, the template. The template is as follows. The template is here. Cn2n plus q moles of H2O with n moles of carbon dioxide and p moles of water liquid. Every book mentions the phase states, so I'm mentioning the phase states, and that it'll be sometimes it'll be a liquid and sometimes it'll be a gas. So you'll have to, and then this will always be a gas, this will always be a gas, and this will always be a liquid. So the first one would be ethene, and the equation balances itself out because 2 carbon, 4 hydrogen, and 2 oxygen. So 2 and 2, 4, 2, 4 and 6. Sorry, 3. 3 oxygen. So 6 oxygen, 4 and 2, 6, 4 hydrogen, and then 2 carbons. The first one would be 1 mole of ethene, 3 moles of oxygen, 2 moles of carbon dioxide, and 2 moles of water. The second one would be 3, 6, 6, and then 6 and 9, so that'll be 4.5. This one would be 4, 4, 8, 8, and then 8, and then 12, it'll be 6. So we can see it's going up by 1.5 again. So if we use 7.5 here and check whether it's right, so it should be 15, 10 and 5, yeah, 15. So this is 10 and this is 5, 15, and this is 10 and that's 5. So that's 5, this is 15, and that's 10. And then this one would be 9. It should be 9 because the increment is going up by 1.5 moles of oxygen. So liquid, 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 gas, 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 liquid, 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 liquid gas. So that's the pink, put states in pink, and then so now I'm going to count. So this is 6, this is 12, so that's balanced. Now we need to check for oxygen. So oxygen is 12 and 6, 18, so that's so that's 9. And then we've got heptene, which is 7 here, 7 here, and so that'll be 14 and then 21, 11.5, sorry, 10.5, 10.5. So what did we notice? We noticed the number of moles of carbon dioxide and is equal to the number of moles of the ethene, the gas, the alkene moles. So if it's hang on, the number of moles, the number of moles of carbon dioxide and number of moles of water produced from 1 mole of alkene is always equal to each other. Okay, so that's that. For example, in this case, you can see 1 mole is producing 2 moles of carbon dioxide and 2 moles of water. 1 mole is 3 and 3, 1, 4 and 4, 1, 5 and 5, 1, 6 and 6, 1, 7 and 7. So we also know that the number of moles of carbon dioxide and the number of moles of water will always correspond to the caliber of alkene. Like if it's a heptane, then it will produce 7 and 7. If it's a hexene, it will produce 6 moles of carbon dioxide to 6 moles of water. For pentane, 5 and 5. Butene, 4 and 4. Propene, 3 and 3. Ethene, 2 and 2. Pretty straightforward. And the oxygen increment is going up by 1.5. So we'll do now. We'll now do octene. And the oxygen would be, I think, 13 or 12. Yeah, 12. It should be 12 because 16 and 12. 12. It's octane. And then nonene would be 13.5, I guess, because it's 18 and then 27, so that's 13.5. So this is how it goes on, and then the last one I'll do for you is this one. So that'll be 10, 10 to the 20, and then 30, so that'll be 15. Was it? Yeah, that'll be 15. 13 and 12, 13 and a half, and 15. That'll be 15. So I hope you were able to make some semblance of how things are with alkenes. Quite straightforward, but they do need a bit of enforcement. So I'd like to go through. Yeah, I'd like to go through this statement. So the number of moles of carbon and water from 1 mole of alkene will always be equal to each other. Please try to understand that. And the number of moles from carbon dioxide and water will always correspond to the caliber of the alkene, which I explained. So if it's 8, it'll be 8 and 8. 9, 9, 9. So there we go. Thank you very much for watching this, and I hope you learned something, and wish you all the best, and I hope you progress in your knowledge of advanced organic chemistry.